Hello students and welcome to Math Weekly number 20. In this Math Weekly, our focus will be on volume. Volume is the number of cubic units that can fill a three-dimensional figure. Volume is consistently related to the lengths that can represent a figure. For this reason, formulas are used to help speed up the process of calculating volume. You are responsible for knowing and being able to use the following formulas: a rectangular prism, a cylinder, a cone, a sphere, and any other prism, which is just calculated by the area of the base times the height. Our focus will be on these four, however. So to calculate the volume of a rectangular prism, you must multiply length, width, and height. Length times width times height. For the volume of a cylinder, you need to multiply pi, which is 3.14, times the radius squared times the height. And remember, exponents come before multiplication in the order of operations, so we'll need to do this radius squared first and then multiply by pi and height. For the volume of a cone, we need to take 1/3 of pi times the radius squared times height. You can do 1/3 times pi first, if you want. You could multiply pi radius squared times height first and then divide it by 3 as well. Those would both give you equivalent answers. Just make sure that you do your radius squared first since it's an exponent and the rest are multiplication. Now for a sphere, we need to take 4/3 times the pi times the radius cubed. Again, doing that exponent first. And you can either do the 4/3 times pi and then times it by the radius cubed, or you can do pi radius cubed times 4/3. And you can use the ABC fraction button on your calculator to help you do 4/3 times that. So let's begin calculating an example of each shape. This shape is a rectangular prism, so volume equals length times width times height. For this lesson, you are welcome to use a calculator to do the multiplication, but you must show your work. So I should see the formula and I should see the numbers that you're multiplying. So for this example, I have length times width times height. So volume is length, which is 6, times the width, which is 4, times the height, which is 5. So I bring my calculator up, I do 6 times 4 times 5 is 120. So the volume equals 120. Now remember, by definition, volume is the cubic units that fill a space. So you should have centimeters cubed, which means cubic centimeters. That's little cubes that are a centimeter on each side. You could fit 120 of those inside this box. Okay, let's look at a cylinder. The formula for the volume of a cylinder is pi times the radius squared times the height. Now, we need to substitute values for the radius and the height. We know the height, but we do not know the radius. We know the diameter. So if the diameter is 10, then the radius would be 5, half of the diameter. So our volume is pi, which is 3.14, times the radius squared, which is 5 squared, times the height, which is 12. Remember, the order of operations says I have to do exponents before multiplication, so I need to simplify 5 squared. So my volume is 3.14 times 5 squared, which is 5 times 5, which is 25, times 12. And now I can just string this in my calculator because it's all multiplication. 3.14 times 25 times 12 equals 942. So the volume is 942. And remember, this is volume, which by definition is cubic units that fill a space, so cubic centimeters. Even though we say cubic centimeters, the 3 comes after the centimeters because we don't want it to look like the number is cubed. If we put it here, it would look like an exponent. Okay, let's look at a cone. The volume of a cone is 1/3 pi radius squared times the height. Now, we need to substitute again values for the radius and the height, which are both told here in our figure. So the volume is 1/3 times pi, which is 3.14, times the radius, which is 3 squared, times the height, which is 11. Again, we must do the radius squared first. 3 squared is 9. So the volume is 1/3 times pi, which is 3.14, times 9 times 11. Personally, I like to do this multiplication first. Since all multiplication is commutative, you can do it in any order. I'm going to go ahead and do these three first, and then to do the 1/3, we'll divide it by 3. So 3.14 times 9 times 11 equals 310.86. So volume equals 1/3 times 310.86. Now multiply 1/3 times that by dividing this by 3, and we get 103.62, and that would be cubic centimeters once again. It could be cubic inches, cubic units, cubic feet. Just so happens that all the examples were centimeters. Let's try a sphere. The formula for the volume of a sphere is 4/3 pi radius cubed. So we'll have to substitute the radius, which is 4. So volume equals 4/3 pi, which is 3.14, times the radius cubed, which would be 4 cubed. Again, we need to do the exponent first. So that means 4 times 4 times 4, which is 64. So volume is 4/3 times 3.14 times 64. Once again, I like to multiply these two first. So I'm going to do 3.14 times 64, and I get 200.96. So I have 4/3 times 200.96. Now my calculator doesn't have the ABC button like yours does in the classroom. So if you don't, this is what you do. You make this over 1 and multiply straight across. 4 times 200.96, so 4 times 200.96, and you get 803.84 divided by 3 times 1, which is 3, and then you just divide it. So we get 267.9, and this doesn't say whether it's inches, feet, yards. So we're just going to put units, but whatever those units are, they'll have to be cubes. So we'll put the 3 behind it. Now let's look at a compound example. A diagram of an ice cream cone is shown below. How much ice cream in cubic centimeters is needed to fill the cone as depicted? So what I like to do is split this into two different problems, and then we'll add them together at the end. So we have a cone with a radius of 4 and a height of 10, and I have a half sphere, not my best picture, but with a radius of 4. So to calculate the volume of the cone, I'm going to do 1/3 pi times the radius squared times the height. For the cone, the radius is 4, so I have volume equals 1/3 times pi, which is 3.14, times the radius, which is 4, but we'll have to square that, times the height, which is 10. Again, we have to do the exponent first. We have 1/3 times 3.14 times 4 squared, which is 16, times 10. So I'm going to do 3.14 times 16 times 10 first. So 3.14 times 16 times 10. So the volume is 1/3 of 502.4. So I'll take 502.4 and divide it by 3. So I get 167 and it rounds to 5 cubic centimeters, but that's just for the cone. Now, for the half sphere, I'm going to figure out what the volume of a whole sphere would be, and then I'll divide it by 2 at the end because I only have half of that. Well, to calculate the volume of a sphere, you have to do 4/3 pi radius cubed. But then remember, I'm going to have to divide it by 2 because I only have half a sphere. So volume is 4/3 times pi, which is 3.14, times the radius, which is 4 cubed, but then I'll be dividing it by 2 because it's half a sphere. Do the exponent first. 4 cubed is 4 times 4 times 4, which is 64. So we have 4/3 times 3.14 times 64. And remember, we'll be dividing by 2. So I'm going to do this part next. 4/3 times 3.14 times 64, which is 200.96, but then I'll be dividing it by 2. Remember, put this over 1 and multiply straight across, so 4 times 200.96 is 803, so I'm at 803.84, divided by 3 times 1, which is 3, and then I'll have to divide that by 2. So I'll divide that by 3, and I get 207.9, but then I'll have to divide that by 2 because it's only half a sphere. So I get 134, because if I round to the tenths, it's going to round up, cubic centimeters. So to figure out the volume in all, I'll have to add the volume of the cone and the volume of a sphere together. So I have 167.5 plus 134 equals 301.5 cubic centimeters of ice cream. So let's summarize what we've learned in Math Weekly number 20. Volume is the number of cubic units that fill a three-dimensional space. Volume is consistently related to the lengths of the figure, and therefore a formula can be used to calculate the volume. You are responsible for the following shapes and any combination of shapes: rectangular prism, cylinder, cone, sphere, and any other prism.